Okay, so hello everyone. I hope you guys are doing great. My name is Sam, and in the last session we were here. So we were creating we were creating the environment Zod schemas for environment variables, so that it will be as of one type. So in the last session was pretty short, and we did not complete the boilerplate. We completed the boilerplate of the code, but we were not able to complete the whole project, of course, which will be a long one. So as we know, in the last session we discussed about how we will redirect the request, the valid inputs from those questions to a web search or an LLM direct call, and which will be taken to the Zod validation and then given the output back. So as we discussed, these are runnables. So runnables are those blocks that you know uh, as we discussed here, you can see in the Excalibur. So these are the runnables. So these are actually basically steps which are in the LLM pipelines. So this will help. This actually takes an input and gives an output basically. So yeah, so for the third one, these two are the input, the results of these two. So it is just like that. So yeah, it's pretty simple, and we will not take much time. Rather, we will start building things. So basically today morning I didn't have anything yet. I hope you guys had a good breakfast and you guys are enjoying this. So basically there will be different models which will be here. So for this there will be llama, I mean for Grok. So for this Grok we have already put there. For OpenAI model we will be putting this topic model. Okay, cool. So we don't have the OpenAI yet. So this will be the OpenAI one. We'll keep this here. So this will be our OpenAI model. Done. Okay, so for Gemini we need to put the Gemini model here. Okay. The Anthropic. Okay, so we'll not take Anthropic model right there. So what we can do is we should go back, structured UI. It was not in the UI. It was somewhere here. Let's see, model. Yeah. Correct. So this is the Anthropic model, guys, and we are left with only, okay, we are not left with anything from here. So yeah, so we have to keep this here as well. OpenAI model. The OpenAI model is chat. Okay, GPT-4o mini. Okay, so we are ready with all our types. So env schema. You can change these models to whatever you want to. It's up to you actually. So yeah, basically all the types are ready to go. I think the last one which is left is search provider. So we are going to put it and then at last there will be table API key. There will not be any default actually. So we are going to use it like this. Okay. Unity schema.parse process.env. So in the last one, I think we used to infer these models via schema export ask result z in 4. So it's like, so in case we need it. If you see from here, type of ask results. This is the type of environment type and environment here itself, passing with the value from process.env. Okay. So here the default one will be grok for us. Yep. So let's implement our model now. And now let's do one thing. Let's keep this env.ts to a folder called shared. A little better. And then again we'll create something called model.ts. So here let's make something called model.ts as well. So these are basically the LC models. So as if you are connected from earlier, then you will understand that we were creating the LangChain models. We were returning the LangChain models to the methods. So if you want to navigate it, so if you do this, so you will see the file names, Control P. Now we'll understand that why we're doing models for that. So whenever we're talking about the LangChain, we're talking about the latest version. Across the vendors, this function will work. It's like vendor agnostic. I mean, it is provider agnostic. So this file will basically give you the portability. You can swap the vendors in the model. So if you want to add a new model, you can directly add it here in this particular function. I think these are the things that are needed. So chat Grok, chat Anthropic, chat Google Generative AI, and chat OpenAI. Yeah, these four. These are actually not limited to these things. You can experiment with more by yourself and then try to apply from these concepts that you are learning. What else we need? We need something called a base chat model, from where we'll be getting the base chat model is. Docs.langchain, of course. Integrations, providers, and then Anthropic. So if you have something called base chat here, if you use legacy chains, the index API or functionality previously re-exported from LangChain community, install LangChain Classic and update. So what's available? The agents, chat models, init chat model, base chat model, unified model initialization. So this actually base chat is used for unified model initialization. So I'll show you how it's done. So we first import this type from LangChain core. So slash language model chat models, language models, chat models. So if I write like this, it will give an error, but if I write like this, it will not give. See, so we are taking base chat model type from there. So what kinds of parameters that we are going to set here? First will be the temperature. Temperature will be low. temperature will be low. So we'll give the model name as well, somewhere around 0.2. Which model actually we are using also we need to mention. So we are going to keep it as a type. So here we need two things. Temperature, as you remember the base we are talking about, it will be a type of number. Let's also take the max token this time. This is also a number actually. Return the options, model options, the basic one, base chat options. So export, this will be a function get chat model. So from the base chat options we will return the chat model. The base chat options is this type. So the input will be model options. This will be the input, the type of actually, yeah. So this will be the type. The default will be an empty object. So we will use the switch keys here. Switch if env dot model provider is present, then what am I using as default? So I'm using grok here. So in case of grok, I'm gonna return new chat grok. So with API key dot grok API key and model, we're gonna give env dot grok model, and again the temperature I'm gonna, and this will so basically we are also having something called temperature. So let's take this const temperature. So this will be ops dot temperature, or else 0.2 will be our default. So this will be our temperature here. So if you see the return thingy, so in this case it will return this, and in default case it will break. Interesting. So for other cases, it will be Gemini API key, Gemini model, temperature, Anthropic, chat Anthropic API key, Anthropic model, and the temperature, OpenAI, chat OpenAI. Here we will write OpenAI API key, OpenAI model, and that's it. In the default case, it will break. The switch cases or model provider will be if it is Graph, Gemini, Anthropic, OpenAI, and in the default case, just break. In default case also. Actually, we can do one thing here. This is okay, it works. So it takes that instance and returns it back. So this is how you can also write default. Like in case of OpenAI, it will also work in case of default. So we'll start working to work with schema. Inside source we can put util, inside util. We'll create schema. Consider these schemas as a legal contract between the backend and the AI model and frontend. Schema is nothing but your legal contract. AI models and to consume. So we need to create quite a few schemas here. So what will the first step? From where we are going to start? The first step will be we are going to create a schema that is going to help us, or simply where we so we type some queries and you hit enter. So we call an API and then our backend is going to consume that input and what is the query that we ask, and based on that we are going to call our APIs, and the AI model is going to decide whether we are going to do a normal search or it will do a website using Tavily. It's gonna crawl some websites and then based on those queries and results it's gonna give some output, and we have to send it in a particular format. So that particular format is a schema that is a legal contract between the backend API and the frontend, which we have discussed often. If you think it's pretty easy to understand, you want it in a particular format, you will get it in a particular format, which is a contract between you and backend. So let's do one thing. For schema, let's import z from zodlib. We'll do z object website schema. Of course. There will be snippet. So you're gonna have title, you're gonna have a URL, and we're gonna have a snippet. So inside this we'll be having a title. So the minimum value will be this much and the maximum value, let's keep it 500. Let's keep a URL. Of course it will be of URL type. Dot string, XAWT type, emoji type, GUID type. So these are the types actually. Dot string. Okay. This snippet is optional and the default is string. This will be our web search result schema. Our express route would pass the request body with this. Then we are simply going to check if this query or sort is missing before we call the new model. We need to see this schema. We need to check this schema because that is going to save our cost. So this will be the type of object, but we also have an array of things, array of these things. So web search result schema, export cons results schema is equal to z dot array of web search result schema dot the max number will be 10. Keep the network and the token users reasonable for the users in this particular case, because we are actually keeping things small. If we are creating any production level SaaS, so we need to understand what is the requirement, and based on that we have to decide all of this. In a project or let's say in a core, it's not possible to explain all of this. What you need to do is you need to get the ideas, and based on that you need to create all. First understand that what needs to be done. The first schema we need to understand because of that. So the implementation of Tabili through web search. So we need to take a type actually first. So we created one util. So within the util, let's create one file called web search. So if I give you one of the high level overviews, first of all, this is actually our search the internet tool. So which means whenever we're going to ask any query, if the LLM decides that for this particular query I need to search for the internet, in that case this function will be called. This is actually the Tabili API, so it's gonna do the search, and based on that it's gonna give you the result back. So this is actually the search the internet tool. So how this is gonna work is you need to give this one a natural language. So this is a natural language query which will be given to it. It's nothing but the user's query. that user is going to type from the UI. Assume you want to get the top 10 football clubs in La Liga in 2025 ranks. So it's gonna call the Tavily under the hood, and then based on the what it's going to return, so based on the result it is going to it is going to return a web search result schema like this and snippet. So it's going to return a clean it. So what is going to happen, let me write it down. Search the internet tools. If redirected by to do so, next it will we give it a natural language query, which will be the user's query basically. It calls Tavily under the hood, so it returns a clean array of search hits actually. So this is the web result search schema. I'm just gonna receive the query, so it's a user query actually. There is no query. Return an empty array, that's otherwise return. Oh wait. So we're going to import something from the env. We need to go to shared and env. We're going to import the env actually. So if you see in the shared, we have env, we will have this env actually. This is not required, but yeah, we're just going to keep it because we have just learned it, right? So that's why we're gonna keep it. Let's go to the API platform of Tavily and we'll see. If you click on the documentation, you'll get the API references. This is a lot of things actually. API references, search, extract, crawl, map, usage, and all the things. So we will not go into the depths of all this. This course is gonna have two parts, of course. So in the advanced concept, we'll learn all this, but for now, we'll start it simple and so focus on the Tavily search. So if you select it curl, basically. Tavily source, call. This is the endpoint. This is what we're going to use actually. So if it was JavaScript, it was like this. Tavily.search wisdom type Tavily core. It needs an authorization where you need to pass the API key, and that's a Tavily API key and what it's gonna receive. It's gonna receive a query. Query is required. So it's gonna search and based on that it's gonna give you a result. There are a couple of parameters based on other requirements are there, like search the depth, control the latency and relevance trade-off, and how result.content is generated, advanced, basic, fast, ultra fast, chunks per source. Chunks are short content snippet, maximum 500, pulled directly from the source. Basic will actually cost 1 API credit. So if you're going to keep advanced, it's gonna cost 2 API credits. So it's up to us. For example, we're gonna use max results. The default is 5. So yeah, these are every other thing that we're gonna use here. Select topic. Let's copy this. And then do a const response. Content type is application JSON. So we're gonna pass authorization key. We're gonna pass it like this. Travel API key. So in the headers actually we need to pass this. Yeah. So it'll be like this. Oh, authorization is already present. This one dot stringify. The query is mandatory, of course. So we're also going to pass something called search depth, which is an enum of string. We should make this one as basic because it's gonna use only one API. If you see here, so yeah, so it's an enum. The default is basic. So highest relevance with increased latency, restore detailed high precision queries, returns multiple semantically relevant snippet per URL, configurable via chunks per source, a balance option for relevance and latency, ideal for general purpose, researches, returns one NLP summary per URL. So it's cool. So you'll use this because we're building something basic, right? So yeah. So search depth. So inside, oh cool. So we don't need to do that. What we can do instead is this will perfectly make it. So if we keep the max result, the number of maximum number of search return to search results to return, yeah, max results due to the maximum number of search results to return. The default is 5, right? So we'll try to keep it 3. Yeah, 5 is also default, but include answer. So if we do this false to both of these things, so excuse me, yeah, so we will search these two things here. Include an LLM generated answer to the provided query. Basic or true returns a quick answer, advanced returns a more detailed answer. Generated answer to provided query. Include an LLM generated answer to the provided query. We don't need from the LLM as well here. Include answer, include image. Not image, it's images. So it's a boolean, also performs an image search and includes a result in the response. Oh, so when the include images is true, also add a descriptive text for image search. Include favicon. Content from selected countries and selected availability. Nice. So if not response.ok, then our search API has failed. So assume we have hit our rate limits or network issues or something from this response. So here we can't directly do console.log and continue in a basic way. So we are going to throw a descriptive error. So our LCELC will catch it. This is actually basically a production good practice. So it's not suggested to skip actually. So I threw something like Tavily error, and then we are gonna log this response. Status, and also we are going to pass the text. So in response we are going to get this result, which result, this result, title, URL, content score, raw content, all this type of things. It's an array. Data dot results. So our result is actually if data dot result is an array, if it is true, then we are gonna pass data dot results, otherwise we are gonna pass an empty array. Okay. So when it's gonna give you a result, we just directly can't return the result. We are actually forcing this particular thing to return it in that format only, in the web search. Normalized result. for each result. Website result schema.parse. Visual.slice from 0 to 5.map for every hour of 5 any. Web search result schema.parse. The title, the URL. But keeping the network and the token usage reasonable for the beginner. Title URL and snippet. Results is an array. We're gonna map that results. Why was I not able to parse it? Oh. Okay. So what are the changes? Okay, my function name was web service result schema. It is what it is. Okay, cool. Okay, got it. My function name was that thing. Same name. So snippet will be the same. Trim it, and in this case we are gonna keep the art.content, otherwise we're gonna keep it like this. We're gonna trim it again. See, we're gonna slice it from 0 to 230. Better. So this is going to give us a safety net, that in case Tablet is going to return something other than this, then sort library is going to throw an error here. That's gonna call a tab based on the API call, and it's gonna give the result based on this. Create our web search logic, and what will be the next step? So a logic for open URL will be created now. Give me some time, guys. I'll catch up. This is just a break. Okay, so as you saw the normalized result, the issue was that we already had that function, so that's why it was not happening. And then in another way, if you see this, then Tavily is probably ready. So our search from the browser API, which will return some web search result schema type thing, is ready. So now for the basic LLM thing, we need to make. So give me some time, guys. Give me some time. Give me some time to fill this water bottle. We'll continue. Okay, so I hope everything is quite easy. second. I hope everything is quite easy to digest. The voice is pretty clear. It sounds like ASMR. I was just checking. Nice. So we'll create another file called openurl. This will be in utils. So this is simply giving us the list of candidate results with URLs and other information. This is going to actually fetch each and every page. The LLM itself cannot directly access or browse web, actually can never actually directly access or browse the web. So whatever code which we are going to write, that is going to act as a browser tool. We decide what container is and what we want to show. So I asked for top 10 IIT in India. There will be so many things like navbar, cookie vendors in a web browser. No, that's not required. We need to fetch the URL, we need to strike all the other information, and we are going to keep all the article like content which we actually need. So what we simply tell that we need to fetch the URL, we need to strike all the unnecessary information, and we are going to keep all the relevant information or the exact article like content that we have fetched. So it's like we fetch the URL, then we cut out or strike all the unnecessary infos we keep exact that's it. So we cut out or strike all the unnecessary information. We keep or extract all the articles for the relevant ones that like content that we need. So that we don't blow up a lot of tokens if we don't do this. So how are we gonna save these tokens? So export issuing function open URL. So this open URL is going to receive URL which will be a string. So we're going to do a couple of steps here. We need to validate. We need to normalize the input URL, and we don't need to accidentally allow files. Only HTTP and HTTPS are allowed here. So this is step 1. We need to validate the URL first. Let's write something called yeah, that's perfect. Regular expression. So this is quite important actually. We need to only check the HTTPS thingy. We have to do this so that we get the secured queries. So some websites they are going to block some generic node fits. So user agent will be agent core plus course demo, and after this we have already created something called save text in the web search. So when we pass, so here if you see, we're taking the response which is of type response, we took the response which is of type response, so we took this response and then we return the response.json. So step 3 is also over, guys. You're fetching that particular thing. Save text. We also had this thing called save text, and then so this is the step 3 right now. This will give me the content type. So if the content type is a raw text, we return the raw text. We are going to convert this HTML into a plain text. A small understanding of browser properties. So if it includes this, then we need another library actually. HTML to text package is there. So you also need types for this, I guess. So we need HTML to text. This will be a package. We also need the DT. nav format scheme. So we need to skip all this nav, header, footer, script, style. So if it is the case, rather pass the raw data. That's it. Tab is an HTML type, then we'll convert the HTML to type text, or else we are simply returning the raw text. We need to normalize the formatting and limit the length. So why we are doing this is going to remove all of the white spaces, and we are going to hard cap to somewhere around 8,000 characters. Why? Because there can be possibility that when this tavil is going to return the result, and we are going to fetch the content of that particular URL, then the content can be very long. This search engine is installing to a documentation website, but there can be like 100k plus characters, so we don't want to crawl all of this, so it will be very expensive call. So we will be climbing that particular to 8,000 characters. Extra spaces will be replaced. SG. Now we want to trim it. This normal text. We're going to create the last step will be we're going to create our structure output. So we are going to introduce another schema. We need need to create one more for this open URL, and then based on that particular format we're going to return that result. This will be the simple schema that we need. The important point that we need to understand here is so the input schema will be like this. Schema will be this. It is downloading the page, it is removing all the unnecessary schema, and it is going to return the article text that we are having. So with this, if for example any site is getting 403 and we got any empty string, this means one can fail. So this means we know that this source is a bad source, and instead of feeding garbage to our trash to our LLM, we should not do that. So again, I'll repeat this open URL function. It is going to fetch that particular page content. It is going to strike all the unnecessary information. It is then going to return the result. There can be possibility, although there are some checks. Page fetching can fail. It can give 403. In that case, these contents, the Zod structure will fail. So that's why we'll get this structure. Return control output schema.parse. Oops. Normalizes our URL actually. The capped is the content actually. Actually, from here we get to know that LLM itself cannot go and search in the browser. It can't browse directly in the web. Only it is feed it. So with this we are actually getting the data. We are fetching the page. Let's see. So we are checking in validating the URL. URL function validates it. It tries to parse that URL through, then return the parse thing. Okay. Yep. So the content, parse the URL and normalized content. We thought that LLM. We earlier thought that LLM itself could go and search from the browser, but with this complete code, we are actually searching. We are getting the data and we are feeding it to the LLM, so that any trash data is not fetched to the LLM. We will keep it to 8000. Getting the content back. So our next step. So we are going to create a summarize functionality. What do you mean by a summarize functionality? It's nothing but it's going to get the information, or it is going to get the content. This summarize function can be used, content can be used. So instead of that, we are going to make the content crisp and clean, so that the user understands this is the content we need. Give me the top 10 movies of all time. So it has to be crisp. So if the LLM is returning a lot of results, so we might be confused. We might to keep the result in such a way, and that we can return the result in such a way that we can cap it to a summarized particular answer. So if you see this is nothing but a function that provides the LLM with a particular answer that it needs, requires. URL fetches the URL. In the header you keep the user agent as this, so that some website block the generic node fetch. So if you keep this, so it avoids instant 403 error. Okay, so that is why I put this. If the response has failed, then we are simply like giving the response back in terms of a message. So if you see the safe text here, it means the response, it takes the response and it gives the response or listen, or it says could not read the error response. It is of type any anyways. Then the content type, of course, it checks if the content type is present or nothing is there. So it does res.text. So it checks if the raw data is text. It makes the raw data as text. It awaits for that function, non-normalized. So if the content type is text/html, then we don't need the raw data. Rather, we convert whatever is present here. It is text data, right? So we convert that raw data into HTML to raw data basically. So these are some of the selectors that helps doing that. Const clean, collapse for white spaces, normal text. The normal text is of course some this, so we will remove all the extra white spaces, and we will remove from the extra white spaces removed, we will slice it to 8000 characters of information, and then we will return it in this particular format. That's it. So we will now implement the summarize functionality. We'll keep another util here. So before this, we're gonna add 2 more schemas. Now you will easily understand what we're doing. So for this one, we're gonna have summarize into input schema. So the same for output as well. So what this is gonna do, So if you go to the open URL, it's gonna fetch all the pages. It's gonna create the content and it is gonna return this a normalized URL and the content which is capped. So in this summarize. The content is very huge, we should not dump all the things. Most of the things are dependent on the schemas that we create. Whatever we receive as an input schema and whatever we throw in as an output schema, not throw, whatever we return as an output schema. Here we need to understand some couple of concepts. So the first one is that when you have a production level application and you are giving services to the user is gonna get some token. So be very careful when returning back the answer, as well as control. So that tokens are not lost, tokens are not wasted. This function we need to validate and pre-process. We're going to clip the source tree before sending it to the LLM. Now here the very important thing is we need to give a limit of characters. So assume we are going to give the limit of 4000 characters, because if the user is giving shorter prompt, so you are going to get a cheaper answer and it will be very fast. The output format will be very consistent in this case. So we're going to create a function. This is going to get two things. Let's pass the text. Pass this one as a raw. Let's give you 6000 now. Once it does the clipping, then we can call the chat model. So here we can pass the particular clip text. This is going to receive the option. So it will gonna receive a max also. So you're gonna return if the length is greater than max, then otherwise this also works. So if the s dot length is greater than max, so s dot slice till max, otherwise return the edge. So ask the model to summarize in a controlled manner for no waste of precious token. If I do const response is equal to await, so now we will invoke it in single message. We can send one message or list of messages. System user, I'm gonna pass it like that. We're going to use the message object actually. System message, human message, a message. All these things also we can use. This one we are going to use from Langsing core package. We're gonna join with /n. This will be our system message. We can use a system message to set the tone. Establish guideline for responses. Represents user input. Clicked. Now the model is going to understand that what I need to do from a system point of view and from a message point of view. We're going to extract the output of that model, what we are getting actually. Based on that only, it's going to give us the response. So this is what we are going to do now. Let's normalize the formatting and let's give a final limit as this is that much final character as a result as I get or as some error I need. need to create this. It's gonna remove all the gaps actually. So basically it's like if it is actually doing a start replace. And it's gonna replace all the white space. It's gonna put it in the new line. If there is any kind of new line with white space, it's just gonna remove all the white spaces. Just return. Up to 2500. So in the end it is what it's gonna return. It is all about this summarize functionality. Once it's going to check all the website, it's going to remove all the unnecessary information. It is going to convert the HTML to text. So this summarize is going to receive the text. It is going to clip first of all. It's going to invoke the model. With the guidelines, what it needs to do. It takes the raw input, normalize summary. So summarize output schema.parse. What do you need to parse? The summary, of course. The model or the schema that we have created for resort, that's about this particular file, guys. So yeah, we'll take a break for this session. I think we will close this session up and then we will start. So if you see here, okay, so I'll explain you what is happening here. We created this summarize function. We made a text raw and we took an input and we passed this text, which we got our text back. Now this is in name of the raw, so we clip this raw. The method clip, what it does is it checks if the length of the string is greater than whatever we have passed. So if it is greater than, then it slices to the max number which is there, otherwise it keeps it that number. So we will get the chat model from here, so from the functions that we have created here, from here. So whatever functions based on the temperature is of course provided, so based on the provider of the model.provider it will work. So yeah, so this is the get chat model function. So it doesn't take the model options, it takes the model options actually. So for options it will take the model options. For this model options it will be empty for now. Base chat model it will return. So ops, it takes ops which is of type model option temperature and max token. So yeah, so it takes temperature, and we can also put max token, but it is optional. So yeah, so now we know about model.invoke. It is coming from, of course, this get chat model which we have created with that particular temperature. So if we invoke, we can write it from this type as well. As earlier we were writing with earlier we were writing in this type, which is like system user. So we were sending this like this, invoking with an array of system, and the content we are passing user, we are in the content we are passing. So it is same as that. So invoke new system instance, new human instance. So we are passing whatever is required, and then the raw model input type of content. If it is of type string from earlier, raw model input response.content, whatever response the LLM gives. If it is of type string, then just return the response.content, whatever content is present. Now how we get to know that it is a content? Now how we get to know that it is a content? Because we already know that it will return some format of content. If you check here, okay, now if it returns the result, it returns as an ask result type, right? So okay, it used to return like this, but if you see here, content, see the content, it returns the content, it returns the content. So so if you see the response, then the content is this. So the response is to await and check the content. So here if you see, okay, anyways, so here if you see, the result is being given to here, but here we are giving the content back. So if it is not in the format of string, we are just returning the string type back. So yeah, so after the raw model output, we are trying to summary. So normalize summary, which means that we are removing all the extra spaces, we are removing all the spaces, we are making it enters, we are keeping all the enters, and we are trimming it there. So raw model in output, whatever is there, we are just having the text back. So now summary output schema, we are parsing the stack to summary output schema, which in return should give us minimum of 1, so not a bit more extra text to summarize. So assume there is 3, we'll keep it 3. So we need a bit more extra text to summarize, of course it will give like that. So this is the thing. So the normalized summary which it does should be around 0 to 2500. So yeah, so whatever the result is given by the LLM, it just normalizes the summary to 2500 lines. That's it. Yeah, so this is the summarize function. It takes a string from open URL, it takes a string and does that, everything. So this is all for this session, guys. I'll be back soon. We will complete this. Thank you. Sayonara.